Hello everyone. Today we are doing the lecture on comparative primate anatomy. You guys have seen me at my best when I'm all dressed up when I come into campus, and you have definitely seen me like at my most kind of, casual. It's fine. I think if we were together longer on the actual campus, I probably would have towards the end of the semester come in like PJs at some point. I think like we all do that, right? First day of school, you want to look presentable, and then later you just don't care, I guess. Okay, so let's jump right in. This one, there's definitely a lot of detail versus, the one we just did on behavior. Not as much detail. A lot of the videos I hope you watched, beyond just the lecture. But jumping into this PowerPoint, so if we're following along with each other. So the first part is locomotion. This is basically how you move about in the world. And so for primates, we consider 4 types of locomotion. There are 5 types of ways that primates can move about in the world, like via their body. Quadrupedalism, and hopefully by the name, this one probably makes sense to you, quad 4. So this is walking on all 4s. The next one, vertical, clinging, and leaping, just like it sounds. We oftentimes shorten this to VCL. So let's say it's on the exam or something, or a worksheet, and you need to write this one. You could just write VCL. That's totally fine. But vertical, clinging, and leaping, it's just like it sounds. These primates will leap to one tree from another tree and cling to the next tree. Then they'll leap and cling. So you can imagine their bodies, like their back legs, are kind of set up to be a little more muscled to be able to push off from one branch to another, right? So their body structure will be quite different. The next one, number 3, is brachiation/suspension. So brachiation and suspension are slightly different, and when we get to that part, we'll talk about the differences. But they are the same in that they're using their forearms, or their forelimbs or their arms, to move about in the world, right? And then number 4, bipedalism. We all are well aware of this one, right? So this is moving about on 2 limbs rather than 4. So this is, humans. We are bipedal. Humans are not the only bipedal primate that has existed. There have definitely been, a handful. We're just the only ones alive right now. Like some of the other apes will walk bipedally, sort of sometimes. Let's say bonobos have been known to walk a little more often bipedally than we kind of see in the other apes. Because even chimps will sometimes walk on their hind limbs, but the whole way they do it, it's not like they suddenly start walking with an efficient bipedal stride the way humans do, right? They kind of waddle a little bit. So they kind of do it sort of, but humans, obviously, we are fully bipedal. So, but we have seen, if we look at the fossil record, we have seen other primates that are definitely bipedal. So keep that in mind. So those are the 4 types. So now I'll go to the next slide. You'll see kind of getting into the details of these types. So the first one, quadrupedalism. So a lot of bullet points, right? We can just go through these. So use of all 4 limbs. Hopefully that's, like I said, kind of intuitive to you. Quad 4, so using all 4 limbs. You can either be a primate that is quadrupedal on the ground, or what we call a terrestrial quadruped, or you can be a quadruped primate that's in the trees, or what we call an arboreal quadruped. Now they're both quadrupedal, but slight differences what we see if you're in the trees or on the ground. So if you're in the trees, you tend to be a little bit smaller in size. If you recall, we talked about this last week with the New World monkeys, who are mostly in the trees, being a little bit smaller. It makes sense, right? If you're in the trees, especially higher up in the trees, you want to be smaller to not break a branch and fall. Be a little more agile, in the trees. And then the quadrupedal primates that are on the ground, they can be a little bit more medium sized to larger, because there's no risk of falling or anything like that. The tail size is often a bit different. So when arboreal quadrupeds, we tend to see the tail being quite long. If you recall from the previous lecture, that's called a prehensile tail, when the tail is often used for a balance or something, versus some of the quadrupedal terrestrial quadrupeds who are on the ground. They have a tail, but their tail is definitely more medium size. they aren't necessarily using it for extra balance or anything the way those in the trees use it. Also, being a quadruped on the ground, especially when looking at the apes, we can see a lot of differences. So you can see in the image here, that's called a langur, that's the monkey, and it's doing what we call palmagrade by quadrupedalism. So like they're literally like putting their palm on the ground and walking, almost like we would if I was like, hey, walk quadrupedally. You'd probably like walk with your hands flat on the ground, right? So that's one type. But then like chimps or orangutans or gorillas, there's variations. They might like kind of be up on their knuckles like this. They might kind of roll their fists when they're walking. So there's a little bit of a difference in the types of quadrupedalism. Also kind of going through that list on the bullet points, you see even things like the thorax, or like this main trunk of your body. Think of like your rib cage. In a human, we are definitely more wide, like side to side and front to back. We're a little more narrow. But think of quadrupeds. Even like look or even grab your dog right now. You'll see like from side to side, like left to right, they are more narrow, and front to back, they're deeper. So even just the shape of like our rib cage and stuff is much different from like a biped versus a quadruped. And then this is a big one, the placement of the foramen magnum. So recall the foramen magnum, that's that large hole in your skull where the spinal cord is attaching, right? Now if you are an animal like a human where our head is on top of our body, that foramen magnum is going to basically be on the bottom of the skull, But in an animal who is quadrupedal, where their body's kind of behind their head, that hole is going to be kind of in the back of the head. So even just the placement of the foramen magnum is going to allow you to determine quadruped versus biped. You could have none of the other bones, but just have like, just the occipital bone, and you would be able to tell if you're looking, at least in a general sense, like biped versus quadruped. So moving on to the next slide. Oh, here's just a side-by-side comparison of the arboreal versus terrestrial quadruped. You'll see, like I said, small to medium, the tail size, and also for the arboreal quadrupeds, their hand bones tend to be a little bit longer, and even sometimes a little bit more curved on the bones. This is obviously, if you're in the trees and you're walking quadrupedally, you're not walking like this, you're kind of grabbing, onto the branch. So evolutionarily, adaptive wise, your hands are going to be a little more suited for that. Next slide. So you can just see quadrupedalism examples, just a handful of different, let's see, we've got 2 monkeys and an ape, kind of showing the variation in how they can be quadrupedal. And then moving on to number 2. So this is vertical, clinging, and leaping, just like the name says. Now there is a link right there to a video that I highly recommend you watch. It's about a certain lemur species, and it's a very good example of what it means they are leaping and clinging, leaping and clinging. So they're leaping from one tree to the next, they are clinging with their hands, so their back legs are much longer and more muscled, kind of similar to a biped. Like our forelimbs are kind of shorter, right, but our hind limbs, our legs are much more muscled and larger and wider. So similar for them because they're using those back legs to propel them from one tree to the next. And then their hands are also kind of made for gripping onto the next branch better. But you'll see in this video, like I said, it's like 2 minutes, so definitely watch it. If a vertical clinger and leaper is going from tree to tree to tree, and there's suddenly like no tree, suddenly like say there's an opening and there's like a little bit of grassy area between one tree to the next, a little bit larger than they could leap, because they can leap really far. They won't just suddenly go on the ground and start walking quadrupedally or bipedally. They will still do this kind of leaping and clinging across the ground, and it kind of looks like they're skipping a little bit. So they will still use this very particular type of locomotion to move about, even if the trees are, there's a little bit further to get to the next tree. Let's see, and then, kind of already said that, smaller body. You can imagine if you are leaping and clinging from one tree to the next, you're not going to be like a gorilla. Can you imagine if gorillas were like leaping from one tree to another tree? That would be insane. So they're definitely smaller. Next slide. Number 3, brachiation and suspension. So recall I said this is using your your 4 limbs or your arms to move about in the world. And there are some different ways you can do this. You can do this kind of slowly, which is what we call suspension. So you might be, you're hanging on here, maybe you grab another branch, maybe you grab some food, maybe you have your kid and you're grabbing onto one branch. It's a lot slower. So orangutans are a really good example of this. They tend to kind of hang a lot. They got a kid in one arm, the females. Maybe grab for some food, and maybe move a little bit. That's, one way. But brachiation, you're still using your arms, but brachiation is you're moving very, very, very quickly. And so the gibbon is a really good example of primates. The ape species, the gibbon, is a really good example of a brachiator. So there are also two types, semi-brachiation and true brachiation. So semi-brachiation, we are used to this, most of us probably got this on the playground when we were little, the monkey bars, right? So you have the monkey bars and you're grabbing onto one and then the next and then the next and the next, right? So that's kind of like what we call semi-brachiation. True brachiation is while you're reaching for the next branch or bar or whatever it is, you've already let go of the other one. So there is a time between either grabbing onto the next one where you are not holding anything. So you can imagine this is very fast and quick. So gibbons are really good at this. And there's a video, I think, on the next slide that'll show the gibbon moving very quickly, and you will see plenty of times it's just kind of flying through the air. But before we get to that, though, staying on the one that says 3 brachiation, some of the bullet points, let's see. So broader thorax, so this general chest area tends to be wider, larger body in general for those who are brachiators. And the scapula. So in a biped, right, our scapula is in the back. So this is also true for those who are brachiators or suspenders. Their scapula is in the back versus a quadruped. The scapula is actually on the side of the arm. Like ours is in the back right here, but theirs is on the side. So even just the general, skeletal morphology shifting. Next slide, you will see suspension versus brachiation. You see that image of the orangutan and the gibbon, and then that video where it's going to show you the gibbon. It's probably 3 or 4 minutes, but you really only need to watch the first maybe 2 minutes to see how this gibbon is moving about very quickly, using brachiation. And then the next slide, number 4, is bipedalism. So this is the one we are all aware of, right? We're all bipedal. So you can see here longer hind limbs or legs. Our legs or our hind limbs are much longer, more muscled, more complex than our forearms, forelimbs or our arms. And the scapula is more posterior. We also, as bipeds, have what's called a non-divergent hallux. Hallux is the technical term for the big toe. So we have a big toe, right? But all of our toes are in line with each other, and that hallux included. All of our toes are in line with each other. We don't have a feature of any of those, toes where one is sticking out to the side. The way our hands are, right? All of our fingers are in line with each other, except our thumb, which sticks out to the side, and we can, touch the other fingers to our thumb. So most other primates have this same hand structure. They have that same structure on their feet, where they have basically their big toe is sticking out to the side. Bipeds don't have that. You cannot be an efficient biped if you have one of your digits in the way, sticking out to the side. So all of our toes are in line with each other. We're going to come back to bipedalism when we talk about hominins too. Next slide, just some bipedal examples. You can see obviously the female human, but also I mentioned here the bonobos. So I mentioned this a minute ago too. So bonobos, more so than any of the other apes, obviously besides humans, have been known and seen to walk bipedally from time to time, more than you might expect. And so I guess kind of the research is pointing to, well, it's only really those who are in captivity, but either way, it still is showing an ape that is walking bipedally, here and there, more so than just the random rare circumstance. And so researchers have kind of, grabbed onto this, and some of the research coming out of this is the reasons why bonobos might be walking bipedally. Does that tell us anything about why early hominins, like those in our lineage, began walking bipedally? So are there similarities? Are there differences? You can imagine this is definitely an area of research. The next slide, diet and dentition. So here we have some dental formulas, which we already talked about. Sorry, my foot's falling asleep. Ugh. Since we already talked about in the previous one where we talked about the diet. So here we have those dental formulas again. So humans and apes, obviously, humans are apes, right? 2, 1, 2, 3. So 2 incisors, 1 canine, 2 premolars, and 3 molars. The old world monkeys are the same, but it's the new world monkeys who have that extra premolar. And then there are 3 diet types listed. Now, in the book, I know that I think it gives you like 4 or 5, but for what you have to know in terms of what I'm going to test you on, it's only 3. So we have insectivore, frugivore, and folivore. Insectivore, it's kind of in the name, right? They're eating mostly insects. And so and remember this, I said, let me get closer to the camera, right? I said on the last one, if there are only like 3 things you take away from this entire class, this should definitely be one of them. If you want to know what a primate is eating, you have to look at the back teeth. If you want to know what a primate is eating, you look at the back teeth. Other, like non-primates, maybe you look at the back teeth, maybe you look at the front teeth, maybe you look at both, whatever. In primates, the front teeth are unrelated to diet. Like asterisk, underline, highlight, whatever. In primates, the front teeth are unrelated to diet. In primates specifically, the front teeth are directly related to sexual selection. If you want to know what a primate is eating, you have to look at the back teeth. So when we're looking at these different types of, diets, we're examining those back teeth or the molars, like what's going on in the differences or similarities between those back teeth or the molars, right? So in insectivore, we can see that they have sharp, cusped molars. So basically the areas of the molar that are raised, for them, they are high and sharp, versus like in a frugivore, they are kind of low and rounded. This is what humans have. Humans, evolutionarily, Homo sapiens, we would be, based on our dentition, would be lumped into the group of frugivore. This is very important that you understand this, because the majority of our evolution, we were fruit eaters. It's only very recently that we are a little more omnivorous, but even with that, there's kind of like some asterisk, like, we'll get into that, I think. I don't know if it's later in this PowerPoint or another, but keep that in mind, right? And then the third type is folivore. So folivore are those who eat plants. So think of like a folivore eating like, leaves and bark and stems, and a frugivore eating like soft, ripe fruit. So, both eating plants, but a little bit of difference between what the teeth need to be shaped for to be able to break down. The gut system is going to be a little bit different, right? So those are the 3. And then also in parentheses, I have something about the tooth comb. So that's that first image on top. So the tooth comb is a feature of the teeth that we see in like lemurs. So the front teeth all here, they all kind of jut like straight out, and they will use this kind of like in grooming each other. So you might hear this referred to as like a grooming comb or a tooth comb. But also remember, lemurs still have a rhinarium, so they still have, even though they have an emphasis on vision, they still have a little bit of an emphasis on smell. So basically those front teeth kind of jutting straight out allow for like a little bit of air to come into that area, and so to kind of aid in scent and stuff. So it makes sense that they still have that feature. But moving on to the next, perfect, like I already said, here we have the gorilla eating leaves. Large canine teeth among primates are not indicative of meat eating. If you want to know what a primate is eating, you have to look at the back teeth. Front teeth, unrelated. In other animals, front teeth, maybe a big canine, direct relationship to their eating meat, but in primates that is not the case. If you see a large canine primate, it's for sure like they're not eating meat. For primates, it's very different. So going to the next slide, you will see examples of this. So here we have the mandrill giant canines, right? Giant canines. Folivore, they're eating plants. They're eating leaves and stems and bark. That's what they're eating, right? It's because their teeth are used for something. Those canines are used for something else. Next slide, you see classic frugivore. Chimpanzee, kind of similar to a Homo sapien. Our molars look very, very, very similar, because evolutionarily humans would be considered a frugivore. But you look at the chimp, you can see massive canines, right? But they're eating mostly fruit. Chimpanzees are a unique example. There have been a couple cases, and if you have taken me in the lecture, you know this, that there have been a few documented cases of chimpanzees maybe eating other animals, but there's a lot of like interesting facts around that, considering like that they're in captivity and stuff like that. But it is an interesting, area of research. However, they've had these giant canines way before this, right? Because it's, for primates, it's unrelated to meat eating. Folivore, the next slide, gorilla, classic folivore, eating leaves. Gorillas are not eating meat. I had someone ask me one time, oh, gorillas eat meat, right? I was like, no. If gorillas ate meat, we would all be dead. Like, this is like a 400-pound animal, right? If they were meat eaters, there would be nothing else in this world, right? So they're plant eaters. Gorillas will eat the occasional like insect or something, but they're mostly eating leaves, like 99.999% of the time. And then the next slide, we have a human mouth, right? So classic frugivore based on our molars, but I have their kind of recently omnivorous. So evolutionarily based, which we'll talk about in the 4th section of this class, meat, animal products have been introduced to our diet, but it's typically in a very small amount. Like our modern, like 2025, like we're going to eating meat all the time, or fast food and processed food, high amounts of meat, high amounts of fat, like that's kind of a whole other topic, But in terms of us and our ancestry eating, even introducing meat in like Homo erectus, Homo neanderthalensis, Homo sapiens, we can save that kind of conversation for a little bit later. But even when we know, there are some species of primates, humans, Neanderthals, whatever, they're eating meat sometimes, look at the picture of our canine. It's not big at all. In fact, it's so small. Essentially, in a modern Homo sapien, our canine's considered another incisor. It doesn't have, you know what I mean? It's not big. So we know at least this thing is that canine teeth and diet are like, there's no 1-to-1 ratio in any way, for primates, humans included. Next slide. So here you can see a chimp. This is like a juvenile chimp, so you can see that the canines aren't large. But what I wanted to point out in this is that the shape of the molars is very different. So if you like look at your own teeth in the mirror, or you are feeling your own teeth right now, you will see that it's very, very, very similar to the back teeth or the molars of the chimpanzee, which, like I said, it's because we are both frugivores or fruit eaters. The majority of our lineage is based on that. So our teeth are what we call evolutionarily conservative. Teeth are very slow to change, and when they do, they kind of take a while to kind of catch up a little bit. So it makes sense that even though, let's say humans, we've been eating, meat, or other varieties of things for, a million plus years, that our teeth are still classic frugivore. And on top of that, also because we process our food. We've been cooking our food outside of our bodies. Like, we're not doing like the chewing or whatever in our mouths. We do a lot of the processing outside of our mouths. Like I said, that's kind of a whole other topic for another day. But our molars would be indicative of us being frugivores, because for our evolution, that's what we did for millions of years in our lineage. Let's see, next slide. Sexual dimorphism. Remember, sexual dimorphism is when there is a difference in size, shape, or color between a male and a female of the same species. So here in this image, you see a gorilla female and a gorilla male. You will see obviously the size difference, right? And the color difference, male, silverback male. And then if you could see, which I have seen, the skeletal shape is quite different. So size, shape, and color. And you can have a species of primate that is a little bit, or what we call slight dimorphism, a medium amount or moderate dimorphism, or a high amount, so like high or substantial dimorphism. Gorillas, orangutans would be considered a high amount of dimorphism. Humans and chimps, like a moderate amount. And then plenty of other species of primates would be low and or be lacking completely. Remember the term, if a species does not have any type of dimorphism, we call them monomorphic. A monomorphic species, primate or otherwise, is when you have to literally look at their genitalia to be able to determine if you're looking at a male or female. Next slide. Social structure. So whether you see a little bit of dimorphism, a medium amount, or a lot. This maps directly onto the social mating structure of that group. So here I'm giving you like 6 different examples. We've got solitary, monogamy, next slide, polyandry, polygyny, and then multi-male, multi-female. So solitary, just kind of like it sounds. So typically, the adults are by themselves, male, female. They might come together at certain times to, be able to mate. And then if it's a female who has offspring, obviously she has then monogamy, one male, one female, and then any offspring they might have. And typically we reference this in terms of like lifelong monogamy. Next slide, polyandry. This is when it's one female and multiple males. We definitely see this in primate. We see this in humans too. It's a little bit more rare, but we definitely see it in humans. Typically, the males are related, and it's usually like 2, maybe 3 males. A lot of reasons why actually this works really well given the particular environment, but we see this in other primates as well too. One female, multiple males. Next one, polygyny. One male, multiple females, a little bit more common in primates, right? So we see here on the image, we've got a gorilla. There's at least, 4 to 5 females there with him. So it's one male and multiple females, right? If the male were to fight another male, it's not as if the loser male gets, like one female, right? It's all or nothing. So they have a high amount of competition. And then 6 is like multi-male, multi-female. The chimpanzee, or maybe even the human a little bit, are kind of good examples of this, where there's not necessarily lifelong monogamous pairing, but there's not like polygyny in either, So this maps on, like I said, directly to the amount of sexual dimorphism. If you look at the gorilla as a very good example, a high amount of dimorphism. They have an extreme social mating structure. Polygyny, right? The males are fighting with other males over access to females. And so the males need to be bigger, larger to be able to fight off other males, right? Some of those features are like the difference between, intersexual selection and intra-sexual selection. Like the male features that are going to be good for fighting other males, bigger, stronger, larger canines to either scare each other off and or use as weapons in fighting. This is what they use them for. And then of course females will find some of these traits attractive and select mates who have those traits, right? So it kind of builds on it. So we see when a species, there was a big difference in the male and the female, a lot of dimorphism. Typically this maps onto some form of non-monogamy. If you are in a species where you're just naturally kind of pairing up and there's no real competition over access to mates, that's a monogamous social mating structure. So gibbons are a really good example of this. They tend to pair up kind of naturally, one male, one female, little to no competition, and they tend to be lifelong monogamous. So keep that in mind with the next slide and the next question. Sexual dimorphism and social structure, you see here, given our moderate dimorphism as humans, are humans naturally monogamous? Biologically, the answer is no. Humans are really good at what we call serial monogamy, S-E-R-I-A-L. We're really good at being monogamous for short periods of time. Like say you date someone in high school, maybe you're together 2 years. Humans are really good at being monogamous, like faithful, only that one partner in that time period, but then we might move on. Maybe you meet someone else in college, you're together, 2 or 3 years, 4 years, whatever, and you're faithful in that relationship, but it just doesn't usually work out. So humans are really good at this serial monogamy, and actually there is an average amount of years that we tend to do this for, and it's 5. Now, evolutionarily, this makes complete sense, because if you are in a relationship with someone, like say human, right, or even thinking of the past, of like in our lineage, that if you have offspring with each other, when would be about the appropriate time in terms of years to leave? Like if you left and your offspring stayed with the other partner, typically the male is the one who leaves, right? In humans, primates, whatever. And the male could still be probably fairly sure that that offspring would survive and thrive, even if he wasn't there to provide time, energy, resources, right? So about 5 years. And think of this in terms of, if I asked you, at what age could a human probably gather their own food, understand, what plants might be poisonous, where to find a local water source. We would probably say, about 5-ish years would probably be like the minimum age of that, being able to do those tasks, right? And so this is what we see, is that it's about 5 years. This makes sense evolutionarily. Like I said, we're really good at being monogamous, but typically for short periods of time. And remember, let me see, I think I've mentioned this to you guys before, but I'll say it again, that most things in life, most things in nature, not all, but most things follow what we call the normal distribution. Let me just draw this for you guys real quick. This is a poor drawing, or what we call like the bell curve. So we could say, for this one thing, or other things, for this one thing, being serial monogamous, let's say we're graphing this, we got some standard deviations for the graph. We would say, the majority of humans fall into, the average and the first standard deviation. We're all really good at, being serial monogamous, of course. You're going to have people at the extreme, a small percentage of the population who maybe have met their person in junior high and have only been with that one person, and they've been together with that person for 70 years. Like, it can totally happen, right? But it's definitely on like the lower percentage in terms of the larger population. And you're going to have individuals at the other extreme who are like, they're never monogamous, they never are in a relationship. Like, these are kind of the extremes. Most of us will fall somewhere in between, where we're really good at being monogamous. We just tend to do it for shorter periods of time. It might take us like to be in like the third or fourth relationship in our lifetime to be like, okay, this is the person, right? A lot of like some social, cultural reasons for that, but biologically, this is typically what we see. Okay, so that is the last slide. So just like I said, to reiterate to you, large canine teeth in primates, unrelated to diet. In other animals, plenty of other animals, you look at the canine, it's directly related to their diet. But in primates, it's not the case. It has everything to do with sexual selection. Those males being able to, snarl, intimidate other males with their teeth, and or actually use them as weapons, which we see all the time, right? Okay, so perfect, right at 30 minutes, and I'll see you guys on the next one.